Welcome to lecture 2 in this product design and manufacturing course. Last class when we ended, I gave a small assignment asking you to do choose 4 different products which fascinates you, and then I hope you would have considered or you would have picked up 4 disassembled, assembled, and then you would have written down the list of all fastening techniques was involved in that particular product. I am sure by doing this exercise you would have understood how different products try to use different technology in assembling and disassembling. So, we will continue with our lecture. So, today we will move to lecture 2, wherein which we talk some more little bit fundamentals of manufacturing, wherein which we keep back of our mind all our focus towards product development. So, in this slide we will try to have an introduction, then capital circulation, which is very important, because when we try to do a product you should also understand what is the capital which is involved, how do I get it out or something like that. So, manufacturing capability, mass production, interchangeability, which is a very important concept, very important. When you talk about product, interchangeability is very important. Then product life cycle, S curve, design for manufacturing. We will just have an introduction in this chapter, but later we will have a complete session discussing about it, and then last will be problem solving process. When we talk about manufacturing, manufacturing is nothing but I take raw material, I try to do a process and I try to get the output. Okay. This process can be, you try to apply either physical or chemical energy, try to change the raw material, either raw material, here you can change the shape, you can change the size, or you can just only change the property to get the required output. When I talk about shape and size, you can use additive process or you can use subtractive process. So, when you talk about processes, it can be classified into 3. One is called as constant volume process, it can be subtractive process, and it can be additive process. Okay. You can follow any of this process and then try to apply either physical or chemical energy to it and try to convert the raw material into a required output. Okay. This process is called as manufacturing, and here when we talk about manufacturing, we have to keep in mind a concept called productivity. So, that means to say with minimum input getting maximum output. Okay. So, here if you see manufacturing, it is a group of operations or activities involved. So, it is not only converting the physical product, it is also involving other organizations or departments in developing a product, wherein which design plays a very important role, planning, operation, and then comes manufacturing production to make a product. You should understand all these things when you are trying to do a product design. The manufacturing system, if you see as such, it is a overall structure which includes not only manufacturing process and production activities, but also the task of finance, marketing and accounting. Today I have a wonderful product, I have a good set of customers for it, but if I do not have a finance to try to improvise the product or to produce the product in mass such that the economics goes down, so then I am in trouble. So, manufacturing is not only producing, but also reaching to the customers such that you try to do it in an economical manner. So, it is now clear manufacturing is not only producing, it involves design, planning, operation, and then you do manufacturing process, and apart from this you also try to do finance, marketing and accounting, all these departments put together in converting a raw material into an useful output is called as manufacturing. And when I do this, I try to do it in a highly efficient manner, that is called as productivity. Okay. So, we will see in this section some basic concepts that are important in the overall understanding of process of development, design and manufacturing. One is capital circulation or production turn. 2 is manufacturing capacity. 3 is manufacturing production. 4 is interchangeability. 5 is product life cycle. 6 is S curve or technology growth curve, very interesting. Simultaneous or concurrent engineering. Design for X, last class I started about design for manufacturing. So, design for X and engineering problem solving. When we talk about capital circulation or production turn, is in context of modern manufacturing, to invest capital from either the profits generated in other projects or taking loan from the bank in the manufacturing facility. So, it is to invest capital in the manufacturing facility is capital circulation. So, it is expected that the manufacturing firm to invest capital in the manufacturing facility to produce goods by using the suitable manufacturing technology and selling the finished products with the assistance of sales and marketing strategy and generating profit. So, this is what is called as capital circulation. So, that means to say I invest 100 rupees, rupees 100. When do I get back my 100 rupees? So, this is investment, invest, and this is get back. When do I get back this rupees 100, and when I get back I will always try to have a profit also with it. So, if I am fat with money, I just invest whatever profit comes, it is all for me. But when I do this investment through a loan from a bank, then the interest of that also has to be taken care, and then I try to make my profit. So, whatever profit comes out, again I will have to pay the interest component, interest, and then I try to get the balance and my balance. So, now I will try to have a lesser amount as compared to if I have a capital which is getting invested from some other place. This is very important. When do I get back my investment, whatever I do? So, why? This is linked to the economics of the product. When I try to develop a product which is 10,000 rupees or 20,000 rupees or a huge investment, so I will not be able to sell that particular product to mass community. So, economics plays a very, very important role when you try to do product design, or in other ways the costing plays a very, very important role. Some part of the revenue is used to settle the amount borrowed, and some parts are used to retain for the operating profit. So, the above cycle works very efficiently when the cost of the production of the good is minimum and the profit is maximum, which everybody would like to have. I invest 10 rupees, if I can sell a product for 50 rupees, I will be happy to do it. But unfortunately, when I invest raw material 10 rupees and other things, the sales component, everything put together, that is operational cost, this 10 rupees will become 30 rupees, and when I sell it at 50 rupees, it is only 20 rupees profit. So, this is very important. If I cannot make a product which is economical, whatever product I do, however good it is, it will not be a successful product. On the other hand, the cycle is obviously less efficient when the production costs are high or the product cannot be easily sold, leading to the inventory building up. So, this inventory building up is another big thing. See, in agriculture, what happens when there is a mass production of vegetables, perishable goods? So, then what do? They put it in the cold storage, wait for a time, and then they disburse it off. So, when they try to do this, they try to have to invest in the inventory storage. So, raw material plus inventory storage, whatever it is, and then whatever is the selling price, their profit goes down because they have invested in the inventory. In the same way, when I try to have sales of textile clothes, if I cannot sell the clothes before the fashion ends or before the season ends, then naturally what I do is I try to somehow clear my textile whatever I have as a clearance sale and try to get it. Otherwise, my inventory builds up and I don't get the return on my investment. So, this has to be taken care when you try to develop a product. When you try to design a product, try to choose in such a manner such that the product can be easily fabricated with low investment and reach out to a lot of people. So, when you talk, this is the nutshell about the capital circulation or the production turn. So, if you look at it, the firm is there. So, sales goods and services, market for goods and services, the firm sells household buying, and from there you see that. So, you see front yellow goes in one direction and the other one green goes in the other way direction. So, if you look at it, market for goods and services, market for factory of production, right. So, if you look at it, let us start from here, firm. So, the firm sells goods and services, and what do the company get is the revenue. Market for goods and services are sold to the household and this is the spending which comes by. So, here market for factory of production. So, here in the factory you will have labor, land and capital which are invested, and then this whatever you get out is going to be income for the household. So, from here you put all the inputs to the firm and wages, rent and profit. So, you have two circles which goes around. So, this is revenue, wage, rent, income and spending. This is all financial. And manufacturing, if you see input, service goods, goods and service and then labor and land, these are the inner circle of it. So, this is the capital circulation or the production turn, which is very, very important. Next, let us look into the next topic of manufacturing capability. So, manufacturing capability is what is the size I can have, I can handle, what is the shape I can handle, what is the raw material I can handle. So, what I can produce is the manufacturing capability. So, manufacturing capability of a manufacturing unit is the limitation of the physical aspect of the product such that the size and weight it can handle, the technology available for processing raw material and the quantity that can be processed in a specific period of time are also constrained depending upon the manufacturing facilities. That means to say, how many products can I produce in 1 hour? So, that is what we are trying to say here, the quantity. So, when you talk about manufacturing capability, size and weight plays an important role. Technology, what do I have? For example, if I have plastic parts to be made, so the technology what I have is injection molding machine. And generally when I talk about injection molding machine, I always have to think of producing lot many parts in 1 hour. So, that means to say the production rate will be very high. When I talk about using the same plastic and then trying to make a composite or just a hull of a ship, the technology which is used is not injection molding. It depends on the raw material. They try to do blow molding or something like that and then try to get it. So, here the number of parts produced is very less, maybe 1 or 2 in a day to get it. So, now the manufacturing facility or the capability is to produce how many parts, what is the technology, what is the size and weight I can handle such that I can try to decide the factory. So, assessed by the limited technology, say for example, if somebody has a factory which is completely working on metals, so then a plastic cannot be worked there. So, that there is a technological limitation. So, for instance, a manufacturing plant meant for automobile cannot produce medicine. So, medicinal products need lot of clean air and it is also have to be maintained, and here it is more out of powder based. Automobiles are metal components or plastic components. So, completely there is a different technology. A company which makes automobile cannot make pharmaceutical and a company which makes pharmaceutical cannot make automobile. On the similar lines, machine have a limitation too. Suppose if I have an injection molding machine, I have a die. For every shot, I get a single piece out. If I want to make lot of outputs, then I will make a die wherein which in every shot I get 6 or 7 parts output. For example, I can try to have an injection die wherein which I make 1 spoon. I can have an injection die wherein which I can make 10 spoons. So, depending upon the shape, size, pressure what I have, the raw material quantity I have, I can try to produce more in number. So, on similar lines, machines have a limitation in the numbers. So, that depends on the shape and size. Producing something in large quantities, mass production. So, here in which if you decide that there is going to be a huge customer bank for your product, then you will try to choose technology wherein which this technology is more focused towards mass. If you decide that I am going to produce Rolex watch and each watch costs 1 lakh, so I will not try to go for mass production, here in which I will go for batch or job shop production, wherein which I try to focus at a customer, try to consider each customer as a prime customer and try to develop my technology and the factory whatever I have in line with the customer, because I can give it at a cost which is on higher side. So, mass production is a concept wherein which trying to produce in large quantities of the same kind of product. Mass production is linked with high demand for a particular product, and the manufacturing plant is generally designed for production of a single type of product. For example, cement, iron and steel, pharmaceutical company, petroleum company. Mass requirement is there, so they will try to tweak to the required customer and try to produce. So, mass production is another concept which has to be considered when you try to do a product design. The next one is interchangeability. Interchangeability is very, very important. When I try to make a product, see, a product can be of two kinds. One, a single part can be a product. Multiple parts assembled together can be a product. When we try to do multiple parts assembly to make a product, then there comes the concept of interchangeability. The concept of interchangeability is try to use parts which are standard so that it can be used for many applications. For example, I have a nut, I have a bolt. Okay, I have a nut, I have a bolt. I pick a bolt from one box and I pick a nut from the other box, wherein which both of them are they both can match and mate with each other. Right. So, if I pick anything out of the 100, I pick any one nut, and a box where 100 nuts are bolts are there, I pick one. Randomly I pick, and if I assemble and if the assembly happens, so there is comes the concept of interchangeability. If I do not want to do interchangeability, the concept of selective assembly comes. For example, if you talk about a plunger and a barrel which is used in a diesel pump, so there we do selective assembly. That means to say the barrel deviations are noted down and correspondingly the grinding happens on a plunger. So, here this particular plunger and this particular barrel alone can mate, the other things cannot mate. So, basically what we are trying to say is you try to specify certain tolerance such that the parts when they are interchanged they can still work. And this concept is very important when we talk about design for manufacturing. As much as possible, when you try to develop a product, try to use standard parts, try to use standard things such that one, for those standard parts you will always have vendors who will be competing and giving you at a price which is economical. Two, you do not have to depend upon one source, you can have multiple sources. So, the advantage is, so you can try to make your product more economical and you can try to make your product very quick. Okay. So, here what we do is we try to make standard shapes and size, give specific tolerance such that you can try to mix and match and mate and start using it for fitting. So, in simpler words, the production process of any part should be standardized to minimize the variations in the size between the parts. So, the concept of interchangeability was a big breakthrough, very big breakthrough in manufacturing. Very big breakthrough. Earlier what they used to do is, when there were a lot of requirements during World War I and II for ammunitions, they always tried to do selective assembly. Their production rate was enormously low. When the concept of interchangeability was brought in, the production of these arms and ammunition shot up very high. The aeroplane spare parts which was being made earlier in non-standard, when they could standardize, the number of planes produced were enormously high during World War I and II. So, this basically interchangeability is, you try to reduce the variation in size and shape and tolerance and try to mete out to lot of applications. The variation should be acceptable in terms of general level of tolerance. So, this is nothing but this is the concept of interchangeability. When you try to do a product design, keep in the concept of interchangeability. First, what you should do, you should think in return on investment or production turnover or capital circular. So, then you will try to look at interchangeability, then you will try to look at mass production, then you will try to look at manufacturing capacity. So, all these things are important because this will try to dictate the costing of your product. Next is product life cycle. It is a time period between conceiving a particular product and a point at which it is not profitable for further manufacturing is called as product life cycle. I start producing a product today, and how long will be the product in the market? For example, when I was young, we used to buy scooters. So, the scooter which in 1980s, the scooter were thought of and had a lifespan of 20 years and 30 years. Today, what we think of any automobile, the lifespan is only 5 years, 7 years, 3 years. It has come to that level. So, what is product life cycle? The time it enters into the market and the time when the product stops making a profit, that is called as the product life cycle. And when you try to look for a product for developing to a customer, always keep this concept of product life cycle in your mind. So, it is nothing but the time period between conceiving a particular product and a point at which it is not profitable for further manufacturing is called as product life cycle. See, today you can take the newspaper industry, you can take telegraph for that matter, phonograms for that matter. So, they at one point of time, telegram was the shortest and the fastest way of communicating or transferring information from one place to the other. In the recent past, telegram is no more existing because technologies like cell phone has taken over. So, if you want to understand little more in detail, first of all, the sale of newly launched product is skyrocketed after its introduction into the market. Once the customer are well versed with the product, sales increases exponentially, and then what happens is it tries to deteriorate. The growth is then followed by a matured period in the sales of further increase. Finally, when the competitive product appears on the market, the sales of the product declines, the market reaches a saturation point and the product is no longer fresh. The sales and the profit further declines and the profit is no more profitable to be manufactured. I have a cycle which talks about it. So, if I try to plot between profit, revenue and profit with respect to time, you can see here I have divided into 1, 2, 3, 4 and 5 phases. So, phase 1 is the product development cycle. So, if you look at it, here there are two things, one is called as revenue curve, the other one is called as profit curve. When you look at it in stage 1, revenue is absolutely 0. The profit goes in negative. That means to say I keep on doing investment. So, when I keep doing investment, I spend lot of money with the speculation that I will win the race. So, when it comes at the end of the product development, when the product has just started selling into the market, I am recovering out of my loss and I am moving towards the zero state. So, as and when it is introduced into the market, you always see there is a slow growth. If you take the slope of this and if you take the slope of this, you see there is a big difference. At this stage, when it is getting introduced by word of mouth, by advertisement or by market requirements, the product gets introduced into the market and slowly it starts moving. When it reaches a growth state, you see there is a rampant increase in the revenue. That means to say number of products sold in the market is very high. And this cannot keep continuing for a longer time. Every company would like to stretch this period, but today because of global competition and so many new players and small players coming into the market, the growth period is now getting down to less than even 1 month. The competition is very high. So, you have to understand this. Then after this, when it comes to the maturity period, you see there is a slowly increase in slope, like the slope value goes down and it reaches a saturation. And after the saturation, there is a deep decline in the revenue. So, when there is a deep decline in the revenue, the profit which was all got about is also slowly started going down. So, this growth period is one thing a product designer should have it in his vision before developing and getting into the market. If you try to do a very small scale or a very small time period growth products, then you will not have more profit zone, and the maturity also will happen very fast and this also will shrink down. So, earlier this lifetime was talked about in years. Today it has come down to months. So, now you see how competitive is the market and how have you to produce or what product have you to produce to sustain it for a longer time. Okay. So, during the saturation period, the profit are maintained by tweaking the product a little bit and relaunching it as an improved version of its predecessor. So, what I am trying to talk about is at this period, maturity period. So, what I am trying to do, I am trying to shift my curve back. I am trying to introduce a new thing. For example, I try to add on some features. I have a car. So, let us assume I am having a car and I am selling the car in the market. So, all I realize is when it reaches a revenue state, what I do is I try to add AC to the car, I try to add music system to the car, I try to add a power drive to the car. Now, what has happened? 3 new technologies have done. So, now I have tweaked up the product little bit. I have not changed the shape of the car, I have not changed the engine of the car, I have not changed the seat of the car, the volume is the same, road clearance is the same, but I have introduced small things in my product such that I tweak it and then what I do is I relaunch it into the market. So, this goes back and starts coming out with it. Okay. When I talk about examples for products in computer industry or in electronics industry, the time span is talked about in months. Understanding of this cycle is very vital for a designer and a manufacturer. If I do not know the time scale of my product which will sustain in the market, no point in developing a product. This is very important. Today, a product is developed because it has to make me economics, it has to bring me some profit. If a product cannot bring me some profit, no point in developing a product. We can always do for a social cause, but social cause cannot be the prime focus of a product design engineer. Okay. To understand understanding of this cycle is vital for designers and manufacturers to maximize the profit and the effort to be made. When should they make the effort, what should they tweak and how do they get it. So, this is very important as far as a product is getting launched into the market. The other one is the S type of curve of the technology growth cycle. So, the technology growth cycle, technology growth is an evolutionary process. So, let me draw a technological graph with respect to time. So, I would like to draw, so this is this. So, this is nothing but technology performance parameter, okay, and this is with respect to time, the same curve like time with respect to thing. So, the first one I would say embryonic, then it is growth, then it is maturity, and the last one is aging. Okay. So, it is almost something like this. Okay. So, here is the new technology period, here it is the technology improvement period, and here it is maturity, and here it is the aging. So, if the technology, so this curve people say it is an S curve because it looks something like an S. So, technology curve is an evolutionary process and it follows a S curve. The S comprises of 3 stages, but here I have given 4 stages. One is slow growth phase, rapid growth phase, and leveling of the phase. So, generally what happens? Embryonic, growth, maturity, and aging. So, all these things come into existence. So, on this plot of 3 stages, here I have given 4 stages, but generally of maturity will be the 3 stage and we stop. They resemble the letter S stretching from the right. When the third stage is reached and the growth is exhausted, that means to say maturity, a paradigm shift is observed and the advent of new technology takes place. That means to say people always at this stage they try to push it back. That is what I was trying to say earlier. It takes a considerable amount of time to master a new technology, but with experience and progress is made. So, improvement in technology is this rapid growth. So, this is improvement in technology. Once the technology is fully exploited and exhaustion stage is reached, very little gain is performed so that the new products are developed. So, let me try to draw the S type curve of technology for the mobile phone, for example, for Nokia phone alone. So, this is performance and this is the time period, time, right. So, this is the curve went something like this. Okay. So, this is the smartphone usage and this is a feature phone usage. Feature phone usage is nothing but the punch type. So, you remember when we were 10-15 years back, this was the phone which came into the market, wherein which you punch the letters, and so this is what is feature phone. The feature phone was going on making profit, and after some point of time you see there is a slow performance decline. And by the time the company could realize that there is a decline in the technology, the smartphone have picked up, and today this is keep moving on. Today this has also come to a saturation. So, what is happening is now new phones come up. So, when smartphone comes here, so let us assume this is smartphone 1. So, now they come out with a new thing called a smartphone 2, maybe a different technology which comes out smartphone 2, then comes smartphone 3. So, like this you see the S curve of technology in the mobile phone which keeps going for a long time. So, the feature phone came first, and after the feature phone came the smartphone. Now, you can see there can be some more advancement in the smartphone. Today, people are talking about watch used as a smartphone. So, you reach all information in your watch, you talk to your watch and that gets connected with the mobile phone. And the next generation, they say you try to talk without making a noise or without making sound. So, that will be the next version of the smartphone. With this, I would like to come to lecture 2 to an end. So, I have a task for the students. This is an assignment. So, here what I would request you is kindly see what are all the developments which has happened, in computers, and how is their S curve for technology. Second thing, what is a biofilter, which is a product, and where is its application? And the third thing what I want is, I want you to look at a recently developed product, which is mass produced. And when you look at the product, it has to be a innovative product. So, please keep this in mind. These are the small simple assignments. You try to look at your internet and try to look at books, and then try to answer these questions. These questions, when you start answering it, you will try to realize how important is product designer's responsibility when he does a new product development. Thank you very much.